All right. So welcome at then the third Rholang office hours led by me. I think last time we spoke about the difference between, or actually the similarity between a constant and replicated received, right? And we actually found out how you can, well, make from a contract a for comprehension, and from a for comprehension, how you should make it a contract. I think this week we can look a bit into join operator, and after that, if there's some time left over, I had the idea to actually show and find out with you guys as well how we can make sequential, how you can do stuff in a sequential way in RChain. So if that sounds good, maybe before I start with that, I actually should ask you if there are some topics or things which you would like to show related to Rholang. And if not, then yeah, I can just go on with the things I planned. But I think first of all, maybe you had some questions.
As far as I'm concerned, join is a very good subject to look at, because I'm very interested in it, and I haven't spent any time writing any code that uses it. Okay,
that's good. So we'll definitely look into that. Adi or Jim, did you have some questions from last week? And maybe Adi, how has it been going with coding Rholang? Did you stumbled upon some strange things which I can explain to you, or?
Haven't really had a chance to do much coding since last week.
Mm-hmm.
So I haven't stumbled across anything yet.
Okay, well, that's fine. Jim, you have some, sorry?
I'm looking forward to, I guess, using the registry and creating a directory of contracts.
Okay.
I guess that's a little, we should get through the basics first.
Yeah, that's more of the, for the advanced office hours. Yeah, that's correct. Okay, well then let's actually go into the join operator and what it actually means. So I'll just share my screen and up. I think well, as always, I really believe in the quality of actually this tutorial. And every time I'm actually just looking into this tutorial and decide what I'm going to do and we'll talk about. So let's see what I write here about the join operator. And maybe first of all, I want to look at this piece of code. So I copy it in RChain.clouds. Wait. Because then you can see why the join operator might be such a good idea. Okay, so what do we see here? On the first line, we're declaring standard out, which is like a special name, namely it prints something on the terminal. And here we are seeing two for comprehensions. First one is being activated if there's a message being sent on the channel Alice launch. And then the second one is being activated when there is a message being sent on Bob launch. And then when both is happening, then we're launching the rocket. So, well, just from this, let's see, first put it like this. What will be the expected output if we just do it in this way?
We should get launching the rocket, or launching the rocket.
Okay, can you explain that to me? Why is it happening?
We put launch on the Alice launch channel, and the first four we see in the list will see launch on their.
Yeah. So X is now launch because that's what's happening, right? Like you bind to X, you bind launch, but then.
Oh yeah, I changed my opinion now. I don't think we'll see anything.
Yeah. Okay, I agree. Because indeed here the only thing which is happening, like just a person is happening, like Alice is sending launch. Well, let's assume it's Alice, but we're still waiting for the agreement of Bob, right?
Yeah. We'll wait for the Bob now, and we'll never see anything on Bob Launch channel, and so it'll just sit there.
Yeah, exactly. So what we want to do right now, we just also want to activate the Bob launch, right? And we do that by sending a message to general Bob launch. Well, we can actually send everything. We don't necessarily have to send launch, but let's just do it in this way. Let's say launch. And what do you expect to see right now?
Well, if we see if Alice launch gets there first, we may see launching the rocket. But let's see if Bob launch gets there first.
Yeah, does it matter which arrives first and which one arrives second?
No.
Well, wait
No.
a second.
Sorry,
We only listen to Bob launch if we've heard Alice launch.
Yeah, exactly. Yeah, so it doesn't matter. Actually, the only thing which can happen here, it can only happen in a COM event on Alice launch, and only after that a COM event on Bob launch. It doesn't matter if Bob launch is first sending on the channel Bob launch. It doesn't matter because there will never be a COM event, because there's only a COM event happening when this one happens first and this one happens second. Only then there can be a COM event, and then only then we can launch the rocket. So it doesn't matter which one is first and which one is second. The only thing which matters is in what order the COM events will happen, and that can only happen first Alice launch and then Bob launch. Right?
Okay.
Okay. So it doesn't. So I was wrong there. It's good.
So let's see. I have here. Can I stop? Wait, what's happening here? This is.
Cannot execute this.
Yeah, it doesn't matter what order it's in, so it should launch.
Cannot execute in stop state unknown. Okay, well that's kind of strange. Let me see to get up another virtual machine. Yeah, I think I have to set up my own one. I hope it works. Yeah. Okay, so it's working. Open my editor.
So why are we using CryptoFX?
Oh, because I'm just too lazy to download it, but I should actually download it. And
I'm not
thank
sure.
you for reminding me again, because I want to do this already for such a long time. But yeah.
Actually, I haven't used CryptoFX lately. I don't know. I probably have to update it or whatever. But we started using Atom for shared development, which was.
Oh, that's nice. Yeah, because in Atom you can actually type along together, right?
Yeah, with what is it? Telegram.
Yeah. Yeah, I know that, and that's actually something I didn't think about yet, but that would be very helpful for maybe office hours, right?
Yes.
Okay.
Yes, we got to do that over when we used the other group collaborative source code editor.
Mm-hmm.
And
it's called Glitch.
Oh, we use Glitch also, yeah. But with the Atom, we get the Rholang highlighting.
Okay, so let me see.
Correct highlighting, not the JavaScript highlighting.
Okay, I get it anyways. Well, what did you say? You can get highlighting in which editor?
In Atom.
In Atom. And you have to download the package, right?
Yeah.
Yeah, you just add the package from the Atom menu. you know,
Yeah.
take a second.
Okay. Yeah, that's really good to know. I'll do that, and maybe the next time we can just type along together. That will also be more interactive, I think. Okay, but anyways, if we do it in Atom, we also have to set up our own standalone node. I don't know if you have done this before, but you can set up your own standalone node on your own desktop, and I like to use this if you just do it for my own
Right.
development
But
purposes.
if we use Atom, you get the changes that I type, and you can run them.
Yeah,
I
exactly.
don't have to run my own R node.
Yeah, that makes stuff more interactive, and then I have to run my R node, but you don't necessarily have to do it.
Right. Or if somebody else wants to use theirs, they can.
Yeah, exactly. But anyways, to set up your own R node, just R node run dash standalone dash no UPnP. I'm not sure what this means, but I've seen people using it, so I just use it as well, and it works. And then what you can do, what you should do if you make your own file. So here I have my 1.row. This is this file which we just saw as well, and then on another terminal, so one terminal I have like this one running, and on another terminal I can do rnode eval 1.row, and then it's going to evaluate, and then we see here the output which you normally see on the RChain cloud, right?
Right.
You see it?
Yeah.
Yeah. So this is kind of it's not super pretty and nice, but
Yeah, it's okay.
we can work this way. I'm not sure why RChain.cloud doesn't work today, but all right. So we launched SignalRocks, but this is kind of bridge how we come to the join operator, because this is, I would say, it's kind of flawed design. And well, what do you think is flawed in this design?
I'm a little mixed up. I mean, first I said it wouldn't launch the rocket if they came in the wrong order, but actually it doesn't matter, right, what order they come in. It's still going to launch the rocket.
Mm-hmm. Yeah, so the only thing which is happening if we launch the rocket, both Alice and Bob has to send a message. But just to give you a cue, like, I think what's the problem here, let's say Alice first says, I want to launch the rocket, and then she just wants to not launch the rocket anymore. Would that be possible in this design? So Alice just makes up her mind. So let's say Alice launched first, she does this. And now she thinks, oh shit, I made a mistake. What to do right now? Would it be possible?
Oh, you could read the, she can, you can read Alice launch and take the message away.
All right, so let me see. Yeah, I think I get your point. So we are reading on Alice launch for and now we have to do this, right? Well, that's it doesn't matter, right? Like this.
Yeah.
Do something here. Okay, but let's say she does this, not in a concurrent way, but like after, like first she sends this into the tuple space, and only after that she sends this into the tuple space. Would it still matter?
Well, if we add in parallel a Bob launch.
Yeah. Okay. So if we add it if we add it in parallel, it might work indeed. But I think what normally would happen, Alice sends it to the tuple space, like this command on line 10, and then only afterwards she thinks, oh shit, I shouldn't have pressed this launch button. I want to reverse it somehow. In this case, it will not be possible for her to revert it to get the command back, because the COM event here already has happened. So we are just waiting here on a message on Bob launch channel. And if this message comes, then we're launching the rocket. Like whatever Alice does here is like she doesn't have any authority anymore. Do you see that?
Yeah.
Right.
So basically, once it's in the tuple space, it's there.
Yeah, exactly. So once it's in the tuple space, like we executed this code on line 3, and we are now in a continuation of this for comprehension, which is everything in between these brackets. So that means that we can just omit this, because this one actually is not on a tuple space anymore, because the COM event has happened, and we are only looking at Bob launch. And if we get a message on Bob launch, and we're launching the rocket. So Alice basically at this point cannot do anything anymore to stop Bob from launching the rocket. So here comes join operator. Will be handy actually to improve this design. I'll just write it down how we could do this.
Yeah, wow, this is cool. I never understood the problem that motivated that particular join operator. Right? This may not be the only one, but that's pretty cool.
Yeah. Well, there's actually really cool use cases for the join operator, and this is just one which is kind of easy to understand.
Yeah, is this the kind of the classical problem that you would want to solve with the join operator?
I think the very classical problem is the dining philosopher's problem, which is like is a classical computer science problem.
Oh well, that's cool. I'm glad you chose to use a different use case, because I didn't recognize it coming at it from this angle, and I'm glad to do so.
Okay, yeah, well that's good, because the dining philosophers this is just I don't know, it's like the dining philosophers, but there's actually, what's the point? We just want to do something when two things happen at the same time. We don't, and that's the join operator. But let me write it down first, and then we can actually see. So I just delete this part, and I put it. I put it here. So this is the join operator. It's nothing more.
Yeah, and if you think of the 4 as being pattern matches, you can think of it in terms of the when command. Yeah, Gary. When this and that and the other thing, you want to do something. If they don't all match, you don't do anything.
Mm-hmm.
And also,
yeah. This is like one giant pattern match, and we are matching the pattern both on channel Alice launch and on channel Bob launch. There must be a send. If not, do nothing.
Right.
And that's this pattern. And well, I just changed the code now. Let me just run it. Well, actually, I should make this 2.row, but never mind. I get on my terminal, which is somewhere here. Now we can see here launching the rocket, which is what we expect. But this is still the same as before, right? Like, let's go back to the problem which I said before. So Alice launch just does something, and well, she wants to stop it, right? So how you can do it, and that's actually what was just suggested. She can do a listen on the channel Alice launch. So let me make this one Alice launch. I don't know, would it work like this if I just do nothing? Standard out. Report. So what's happening now? Alice is sending something here, Alice is taking away, and now actually I want to make it sequential, which will be a nice bridge to the next one. Because I want the stuff to happen in a sequential way. Because if I do it like this, it can still happen that the rocket is launching, but I want to kind of mimic how first Alice launch would put something and then Bob launch. So let me do that. Hoi.
So if we ran this several times, we would get different results, right?
Yeah,
Sometimes,
exactly.
sometimes it wouldn't.
So I'm now just introducing a new channel, AC, and AC I'm going to use to make actually stuff sequential, which is like a really nice bridge into the next one. So let me look how to do this. So Alice launch is sending on launch. Yeah, and then how can I do this? Would it be possible? Can we ensure that we're only executing Bob launch if and only if we have red from Alice launch fire here? Yeah. Okay, that's possible. We are sending on Alice launch. Then we are sending on AC. Sending nil on AC. If we get stuff on nil, oh no, if we get stuff on AC, then do this, and I'll explain later why I'm doing it in this way. And sequential to that, we also again send on AC, nil, and we're listening again on AC. And now we're going to do a Bob launch.
Okay, the other way to do this is you could have first done an eval of
oh yeah, that's possible as well. But
you could have done, done an eval for Alice launch, then an eval.
Yeah.
For
That's true. Yeah.
Okay, and what we're doing here is we're simulating it. This was done first, this was done second, this was done third.
Yeah. What you say is correct. Like we could also just have done an eval and just actually send it ourselves sequential. But I prefer myself when I test stuff not to do everything manually and just code it here, and that's what I did. And I also think it's a really nice bridge into the next one. So just for now, I think just you can take my word for granted that I'm first doing this on Alice launch, then by means of this construction, I only do after that. So here is Alice presses on the button, and then here Alice cancels the launch, and here Bob tries to launch, right? Okay, let's see if it works. Wait, syntax error 19. 19.1. That's here. I didn't. Okay. See, this one is ending there, and that should not end there. Should end. Okay. I did something wrong with the brackets. See, this one is correct. Let's launch here on ACK. Here's a 4. Here another 4. This one there. Ah,
Nah,
here, right? Yeah.
better.
Yeah, got it.
What did we do?
Up. So I added one extra of this one, and that's why I made a mistake. So now it should work. Oh, another one. 13. Yeah, do you guys see what's the problem here? On line 13, I'm making an error, it says.
Need another par.
There you
Yeah, exactly. Yeah. So it says the problem is on line 13, but actually it's on line 12. It just tries to interpret this, but it was expecting a bar. So, yeah.
Well, you could have put the par on 13, but the
Yeah, I could have done that, but
style is to put it at the end, right?
yeah, exactly. Oh, wait. Alice launched at 11:14, so that actually is nice debugging. Yeah. Okay, so what's the problem here?
Quotes? Oh, at quote.
That's well, because this one would be free variable, and that's not possible. So if you want to, like here, I'm sending on at Alice launch. So here I also should listen on at Alice launch. Do we have all them? Yeah, I think so. Let's hope. Yeah. Okay, let's see. This is the output. It got reverted, and there's no launch of any rocket whatsoever. And now we can actually do what you just said, because now if so we have this, so we are, well, Bob launch, this one is currently sending. And okay, so this is being populated. Now I'm just saying, let's see if it worked, because I never do it in this way. At Bob, is it with the capital? Yeah.
Alice launch.
Oh yeah, Alice launch. Because Bob launch is already there.
You already did the Bob launch. Now Alice changed her mind again. She wants to launch.
Yeah. So let's see. Look, let me get before what I had before, so you guys see it. So
You don't need anything else. You'll get the output. The rocket is launched.
yeah, exactly. And why? Because like here, Alice reverted. After Alice reverted, we are sending a message on X. So then afterwards, Bob is trying to launch. So at this point, what is in the tuple space is still this one on line 3 with the continuation, and the fact that Bob is trying to launch at this point.
Well, wait a second.
Mm-hmm.
Okay, so we got the act. We got the act. Wait.
Please say the line number. I can follow.
Okay, we got the Alice launch reverted, and now we have an act. Okay, and because we got that act, Bob tries to launch.
Yes.
Okay, so the Bob launch is in the tuple space.
Mm-hmm.
Can we see that in the output that the Bob launch is there, or does it show?
Let's see. Yeah, it says here.
Okay.
And I think maybe it's also here. Yeah. So here, you see, I'm doing many things on this, but somewhere here we should find Bob launch.
What? Oh, yeah.
This is my tuple space, but I mean it's like
Huge.
it's huge, yeah. But there should be number. Well, just take my word for granted like that. Oh yeah, here launching the rocket. Yeah, here. See, this is listening on Bob launch, launching the rock. We're
Move your
sending us.
cursor over it. I can't see it.
I also can't see it, but
Highlight it.
it should be there. I mean, and then, well, what we're going to see now, if I send on Alice launch, then I think that line 3 will be executed because it has something in Bob launch, it has something in Alice launch, and then I'm expecting to see launching the rocket. Let's see if that's the case.
Yeah, it's launching the rocket.
Yeah.
And
Okay, so that's the join operator actually, and actually that's also to do the sequential stuff.
yeah, that was good. An interesting thing to me is that by definition, the join there is that Alice launch and Bob launch are simultaneous.
Mm-hmm.
Okay, and yet in an asynchronous network, nothing is really simultaneous. But we're sort of
Well, it is simultaneous, yes, but you have to take into account that once you send on a channel and the send is not being absorbed by another receive, right? It just keeps on sending, and if it's there, if it's in a tuple space, it will stay in this tuple space unless somebody actually eats it, right? So it is simultaneous, but not really, because it can also just happen after each other. The only thing which happens is needed is that they're both like simultaneously sending, but that doesn't mean that one cannot be sending already for a really long time and the other one is just sending for 1 millisecond. You see?
And if Bob sends from one side of the network and Alice sends from another side of the network, it could be either order. We don't know, as long as they're both.
Yeah. So if Bob sends it, then this one will not be eaten up, because the only way how to eat it up in this context is if there's also an Alice launch. Then the COM event will happen, and once the COM event happens, then this message launch will be disappearing from the tuple space because it's being, it just disappears by means of the COM event.
Can you run the Alice launch again?
Yeah.
Oh, I thought that was a separate file.
No, but I can do it like this. Is launch. And by the way, we don't have to type here launch. We can also just send new, right? Because there's nothing checking for actually launch.
That should be a global name, right?
Wait, yeah, indeed, that's not possible. So let's just send. I mean, this doesn't mean anything, but it's nothing.
You need quote Alice launch.
Oh yeah, at Alice launch. Yeah, thanks. And then we can actually send Neil here. Yeah, and now let's send on Bob launch. And we're also still not seeing anything. So like this is just, I mean, in RChain, there doesn't always have to be first the send and then a receive. It can also happen that there's first a receive and then no. It doesn't matter. Like for now, I just propagated the tuple space with Bob launch and Alice launch, and now I'm actually going to propagate the tuple space with this join operator in the for comprehension. And
now, if we did a persistent listen here, then
yeah,
then it would have launched already, because we still would.
oh yeah, exactly. We didn't do a persistent here, so that's why it was not launching already. And now if I just put this one in the tuple space, then I'm expecting it to actually launch. Yeah, see here?
But, yeah. Launching the rocket.
Okay, maybe let's do one more example of the join operator. Do you guys like see it already, what it means and what we can do with it? There's one really nice other example which you can show as well, but if not, then well, for me, I did like the sequential, I did the join, so kind of done there. Do you guys want to see another example, or is it good like this?
Well, I'm curious to know what your, is it another use case you're thinking of?
Yeah, it's another use case, another example.
For join?
Yeah.
Yeah, I'd like to see it, because these are enlightening to me, that both the dining philosophers and then this one, which is more of a revocation of a signal.
Okay, let's actually go just over the dining philosophers, because did you already check this one or not?
I did, yeah, and it made sense to me, but one of the things that I was thinking about when we did the dining philosophers was, well, I'm having trouble imagining a different scenario here, but I think the revocation of the send is a good enough use case for me, and I can see that you have all kinds of different permutations of those revocations.
Yeah. Okay, well, let's just do the other one. I just copied it from the tutorial.
And what is this example?
Yeah, so this is also an example of, let me look quickly.
Patience. I haven't seen the dining philosopher.
Yeah, I could look at that one again myself.
Let's look at the dining philosophers, because I'm actually like, this one I know kind of myself and this one I don't, but that's, maybe we can just together look at the dining philosophers, and with the knowledge right now of the join operator, see why it makes sense.
So
and
the dining
also for me, it's a long time ago I looked at the dining philosophers, so like I don't know, but I think we can figure it out together.
So we have just two philosophers in this case, one at the north end, one at the south end. Have one knife and one spoon.
Yeah.
And they need both the knife and the spoon in order to eat, or how does it work?
Yeah, so indeed, like there's a table and there are two philosophers, and one philosopher sits on the east side and the other one sits on the west. That's what you told already. And they both need a spoon and a knife to eat. And then the issue is that's
and they won't put it down until what?
Yeah, so if they both reach out to the utensils at their right, they will both never be able to eat, because philosopher 1 will get the knife and philosopher 2 will get the spoon, and they never let go, right? That's what they say is the problem. And let's see, that's actually, yeah, so here you see on this thing, like you see, we put on north a knife, we put on south a spoon, and here we are seeing philosopher on the north side reaching out to the knife, and he is also reaching out to the spoon on the south side. And when that happens, he is finished eating and he puts the knife and spoon back. Whereas the philosopher on the south side reaches first out to the spoon, then he reaches out to the knife, and then he's complete and then he puts it back. But what's happening here is that one philosopher will get the knife, the other one will get the spoon, and that's it, right? There will never be sand on south, and it will also never be sand on north, because neither of them finishes.
But is it, on this particular example, isn't it possible that this could actually work occasionally?
No, because that's the way how the commie, like, as far as I get it, the commie fans, they just happen in a kind of, they're that's actually a very good question, but in my experience,
It's possible that North could get.
Both.
Wait.
no, yeah, well, it depends how these commie fans are being evaluated, but as far as I get it, they're first evaluate all the commie fans which are happening on, like, first inside this scope. So that is this one and this one, and after these are being evaluated, only then we are going to the next scope, which is one layer deeper. But actually, we can just check it, like, because that's my experience. But that's
will this lock up the? Will you have to reset if you run this because it is the deadlock? Or
let me see. I'm just going to run this, and maybe RChain CoLab Rholang works.
Yeah, no, it won't deadlock. I mean, it'll just stay in the tuple space. It won't lock up anything.
Yeah, exactly. It will just stay in the tuple space.
Okay.
I'll just put it here. And let's just run it a couple of times, because that's the only way how we can verify, right? That there's actually deadlock happening. No. 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 No.
Okay.
Yeah.
Well, I'd have to walk through that to convince myself that it will never, that it could never happen. But that's a pretty good sample.
Yeah.
I think, in general, when you have the parallel in here, you can think of them as, you can think of them as perhaps running at the same time, one running to completion before the other one starts. Or
yeah, but that's yeah, but that's not how the virtual machine of Rholang apparently works. Because this piece of code, we're doing this sequential, we're doing this sequential, we're doing this one sequential, and we're doing this one sequential, and only after all the common events are being, like, resolved in this scope,
yeah,
then we're going to look into the next scope.
They're not sequential, though. They're, in theory, they're not defined to be sequential. They're defined to be asynchronous.
Yeah, concurrence. Oh, sorry, I said sequential. Yeah, I meant concurrent, indeed.
They're current, right?
Yeah, yeah. Thanks for correcting me.
Okay, but if it's running the first 4 and the second 4 concurrently,
Yeah.
then cause.
Yeah. So this is just saying like.
I don't think you can. I don't think we can say they started at the same time though. It works out. So it works out. So at least as many times as we tried it, it never got into the 4 before. Before they got the South Spoon.
Mm-hmm. Well,
but I don't think there's anything in language that would prevent that from happening.
Mm-hmm.
I mean, if you let's consider the case of we're across country again,
Mm-hmm.
and I enter a 4.
Yeah, because you're saying like because of network latency and everything, like it can be evaluated in a different way at every different point in the tuple space, right?
Yeah.
Yeah, I think yeah, I understand that, but I think you should see this as a kind of subcontract which might be executed if or there's inside a continuation of another for loop, and in this case it will happen at every point in the channel at the same time. You see what I mean there?
I'm not sure what you said. That's okay.
Yeah, but I see your point, because like due to network latencies, like here it's very neat in a smart contract, right? And it's all concurrent.
Yeah.
If there's actually a real philosopher somewhere in Australia and a lot of philosophers somewhere in Dubai, or one philosopher has a very fast computer and the other one is just running something on his smartphone, due to network latencies, actually it might happen that this is being resolved before this one is even known to the network, right? That's what you're saying.
So what we're saying is they actually might get to take one bite, and then they would put the fork and spoon down, and then it would probably lock up again.
Yeah.
I mean, we could try it on the master network.
Yeah, but I'm sure that
I could enter it on one node on the master network,
Mm-hmm.
and propose a block. Okay, and you could enter it on another node and propose a block. Now we're not going to propose the blocks at the exact same time.
Mm-hmm.
So whichever block gets done first is going to execute to completion before the other one.
yeah, the first one is always going to execute.
I think this one would be more realistic, and which would not depend on any assumption.
Well, you're assuming they're running on the same node, right? It's not the decentralized case. If you run a 4 on one node and propose it, and a 4 on another node and propose it.
Yeah.
Okay, that's when we're going to have the issue that we're going to where they could eat.
Does this make more sense? Because if I do it like this, then we're not like depending on any network stuff, right? Like we're just deploying, let's say a contract, we call it stored, or let's say dining philosophers. And if there's a message on dining philosophers, then we are actually starting this whole problem. And now we're not depending on any latency anymore, because this is just how it's being evaluated inside the tuple space.
Right. You're saying that both north and south are in the same place on the same node running this,
Yeah.
They're not separated at all.
Yeah. Yeah. And I think this is also like a theoretical construct. Yeah.
No, I think the same thing applies if it was the same thing applies if it was a DApp, if it was a distributed application. I think the same thing applies, that we can resolve it using the join.
Yeah. Let's look into join, because actually that's like how they solve it here. And then you directly see why the join is useful in this example. So we just start with philosopher, north, south, knife, spoon. We're putting on north a knife, putting on south a spoon. So far everything being the same. But then here we are, instead of first grabbing for the knife on north and only then grabbing for the south on the spoon, we are doing this join operator. So we're, actually this is saying like we grab on north and south if there's something to grab, and if not, we don't grab at all. That's what it's saying actually. And so they do this, and philosopher 1 will be complete and puts it back, and then philosopher 2 will get it and put it back, or it just happens in the other order. But anyways, they're not getting into this deadlock where one has a knife and the other one has a spoon, because that will not be possible in this construct.
Yeah, in this case, for me, the one that works with a join makes a lot more sense than understanding how the one that doesn't use a join fails. But I know that the dining philosophers is the classical deadlock use case.
Mm-hmm.
Yeah, and in this case, it doesn't matter if north is on one node and south is on another node.
Yeah.
In either case, the nothing will happen until both messages are there.
Yeah, that's true. So this is just preventing the deadlock. And indeed, like here, you can say, well, if they're somewhere else in the network, then it might happen that we actually resolve this into completion. But you're never completely sure. It could happen that this is actually being executed really at the same time, and then you end into this deadlock, and then, well, both starve to death, and we don't want that. And using it here with a join, it just prevents it. It's never possible in this situation to get a deadlock.
Excellent.
Yeah.
Good. Yeah.
Okay. I think it helps. I hope so.
That helps.
Was a pleasure. I'm not sure whether I'll be hosting this one this week, but next week, because there's also a bit of pressure on the budget from my side, and I'm having like really limited time. But let's see. I'll talk about that in like the upcoming week. I'm not sure what I have to decide myself yet, but
Sure.
maybe this will be like last from my side at least. But yeah, let's see.
Okay.
Yeah.
Oh,
All right, guys. Anything else before we sign off here?
no.
For me, nothing. Thanks for the participation.
Okay.
Thank you, Rinka. This helps a lot.
I'm happy to hear that.
Okay. See you later.
Yeah, we'll see you later. I'll hang around a bit.